this looks like a pretty straightforward question, actually. So if you don't remember what these definitions are, you can write down the formula. No, you're not letting me finish. B1A. So your formula is Q equals CV, so C equals Q over V. So you could say then farads are the units of capacitance for capacitors and are defined as 1 farad of capacitance means that a capacitor will hold 1 coulomb of charge per 1 volt of potential difference across it, or something along those lines. You know, you have these in your notes. In the marking scheme, he went for the farad. The farad is the charge in coulombs which a capacitor will accept for the potential across it to change it by 1 volt, or any other correct definition. Anyway, no, don't write that down. That's stupid. You have it in. You have this. This is disgusting definition. You have a nice definition in your notes. All right, as you wish. But I'm going on to the B part now. Right, B. No, be quiet. Let me do it first. Determine the combined capacitance. So you have a 4 micro, a 12 micro, and a 6 micro. So we'll add the 12 and the 6 together to make, so here's a 4 micro, and now this one here is a 18 micro, and now we add these together. 1 over C is 1 over 4 plus 1 over 18. So that means the capacitance is 3.27 microfarads. Okay. So far, so good. Next. So C is again, C is pretty straightforward. Yeah, it's a half CV squared. So let me see, a half. Now, is it the C from the last part? No. No, it is. Yeah. Actually, you don't need to use this formula because they give you the Q. Well, hang on, let me just think, please. You have work is a half CV squared, or the other one is work equals QV? A half QV, yeah, for this one. Huh?
No square?
No square. Wait. Yeah, no square. Yeah. These are the two formulas. Yeah. So it's a half times Q, which they give us, and the voltage, 80. Alright, so what did you get, Tekken? No. No.
8?
0.8. 0.8. joules. 800 millijoules. Congrats to you. But what did you use as the C? The previous answer? No. They didn't tell us that was the same as part B. So, no. And in fact, in part 2, they want the C. Oh, yeah. C equals Q over V, which is 0. What's the Q here? 20 milli. Oh, wait. I apologize. Here's me saying that you're off. No, actually, no, I'm right. Sorry. Right. Q over V. So, what's the Q? 20 milli. And the V? 80. So, 250 microfarads. Okay. Part 3 now. Can I? Oh, I'll let you catch up. And this is actually a good exam, this one. Huh? Say again, Fahad? Yeah, the next one is actually just a graph, isn't it? Right, so let me just make the table here. So we have time in seconds, and then we have voltage in volts. So the time is 0, 10, 20, 30, 40, 50, 60, and the voltage 80, 72.2, 68.4, 60.9, 56.7, 51.9, 48.4, and they want you to add in log of volts in volts. So that would be log, hold your horses, log here. Yeah. So we'll just copy those down. That's an easy 2 marks. State the relationship which shows how the potential difference depends on times. And yeah, so this one's a small proof. Let's look at the proof here. Oops. What's wrong with you, KJ? I said it's a small proof. So, part 1 I just did. Part 2 now. You have the formula that B equals V0 E minus T over time constant. If you put log on both sides, you get log V0 E minus T over time constant. Log V equals log V0 plus log E minus T over time constant. So you get log V equals log V0 minus 1 T over time constant. So you have log V equals minus 1 over time constant T plus log V0. So if you make a plot with log V on the y-axis and time on the x-axis, you can see that the slope is minus 1 over the time constant, and the intercept is log the voltage at the beginning. And that's the end of the proof for part 2. Now part 3 is the graph. So we'll just draw the graph here.
The values are right, right?
We'll,
Y-axis and x-axis.
we'll see now. I should have a downward graph.
Upwards.
No, look down. This is question one. Log voltage against time. And the x-axis is time in seconds, and the y-axis is log volts in volts. So that's the graph, and of course they want you to draw a straight line. And that's our graph there. Now, we have the advantage of seeing exactly what the slope is here, but in the exam you would need to estimate it from the triangle. So what you do is you draw a triangle here, and you do the delta y divided by the delta x. So the delta y for me looks like 4.4 minus 3.85. And the delta x, well, the delta x is easy to see. What's the delta x? That's just a 60. 60 minus 0. So my slope I got estimated is 0.009, and the correct answer is 0.008. That's okay. Well, 84. So it doesn't matter. I'll use that one there. Minus 0.0084. Yeah.
But we used to use 0.85 because it's now 9 or 8.
How? I use 0.85?
Yeah.
3.85?
Yeah, sorry.
Oh yeah, 3.85 is a little bit too small. Should be more like 3.88 maybe. Yeah. Okay, so anyway, it's minus 0.0084. So for part 4, you get the slope is minus 0.0084. So therefore, the time constant will be 1 over 0.0084. So for the time constant, I got 119 seconds. And lastly, part 5 is what is the value of the resistance. So which formula do you use for that one? Which formula do you use? Time constant equals RC. So R is time constant over C. Now do we know the C?
Yes.
Do we?
Yes.
Did I? What's the C?
250.
Oh, is that the part really early?
Yeah, micro.
This, yeah. You'll have to remind me what it was. What was it? 250 micro. Okay. So I got a pretty large number. I better put it in mega. About half a mega. Yeah, which is matching up with the book here. 0.476 mega ohms. B2, yeah. Maybe I'll let you start this one because I won't get. Well, will I get it done in 10 minutes?
When are you doing?
Today is a bad day for me. Wednesday's better.
You don't have a lunch break?
Oh, lunch break, yeah. Do you know what? I think I can do B2 now if I just skip the definition at the start.
Yes.